In this video, we will write each vector in component form, and then we will state the magnitude and direction. This is unit vector form. For number 1, component form would simply be 3, -4. To find the magnitude, we will do the square root of 3 squared plus -4 squared. That's going to be the square root of 9 plus 16. That's the square root of 25, which is 5. So the magnitude is 5. Now for the direction. This vector goes right 3 and down 4. That's going to put it into the 4th quadrant. Now let's start by finding this reference angle. I'm going to sort of build a triangle out of it around the reference angle. If it's right 3 and down 4, we can find r by doing the tangent of r, which will be 4 over 3. I'm ignoring the negative sign because I just want the positive value of r. R will then be the inverse tangent of 4 over 3, which I will find on my calculator. Inverse tangent of 4 over 3, 53.13. Now, the actual angle that we want, the direction angle, has to be measured all the way from the positive x-axis counterclockwise. Let's call it theta. Theta was on its way to 360, but it had to stop short by the amount of r. So theta should equal 360 minus r, which is 53.13. So that is 306.87 degrees for the direction. For problem number 2, the component form would be 9, 1. For the magnitude, we will do the square root of 9 squared plus 1 squared. So that's 81 plus 1. So that's 82. So the magnitude is the square root of 82. This does not simplify any further. Now for the direction. This vector goes to the right 9 and up 1. That puts it in the 1st quadrant. I'm not drawing this to scale. We will not need a reference angle as a middleman. We can just go ahead and find the direction angle directly whenever it's in the 1st quadrant. So since this is right 9 and up 1, we can find this direction angle by doing tangent. So the tangent of theta will equal 1 over 9. That means theta should equal the inverse tangent of 1 over 9. So consulting the calculator, inverse tangent of 1 over 9. That is 6.34. degrees. Alright, so that's the direction for number 2. For number 3, component form would be -5, -5. To find the magnitude, we will do the square root of -5 squared plus -5 squared. That is going to be the square root of 25 plus 25. That's the square root of 50, which of course is the square root of 25 times 2, 25 being a perfect square. So this simplifies to 5 root 2. So that's the magnitude 5 root 2. Now for the direction. This vector goes left 5 and down 5. So that puts us in the third quadrant. We will need to start by finding the reference angle. So left 5 and down 5. We can find this reference angle using tangent. The tangent of the reference angle will equal 5 over 5. I'm ignoring the negative signs. That means the tangent is equal to 1. We don't need a calculator for this. This is a fact that we have memorized. The tangent of what angle is equal to 1? Well, we know this is going to be 45 degrees. All right, that's one of the ones we memorized. All right, but if somehow you didn't know that, we could do the inverse tangent of 1 to find this reference angle. Whoops, that's not my calculator. So look, just if you follow the same pattern, inverse tangent of 1, but we already know that was going to be 45 degrees. Okay, but the actual direction angle has to be measured from the positive x-axis like this. So that's going to be 180 degrees plus 45 degrees, or in other words, 225 degrees. So that will be the direction for number 3. Number 4, the component form. This is like a -1. So the component form will be -1, comma 4. Now for the magnitude, we will do the square root of -1 squared plus 4 squared. That's the square root of 1 plus 16. That is the square root of 17. So that's the magnitude. For the direction, this is left 1, up 4. That puts us in the second quadrant. We will need to find a reference angle first. Okay, this is not to scale, but this is left 1 and up 4. We can find r using tangent. The tangent of r will be 4 over 1. I'm ignoring the negative sign because I just want positive r. So the tangent of r is 4. That means the reference angle should be the inverse tangent of 4. So let's check the calculator. $75.96. Okay, now the actual angle has to be measured from the positive x-axis. So this was on its way to 180 degrees, but it had to stop short by a value of r. So this direction angle theta should be 180 minus the 75.96. So that's 104.04 degrees. That is the direction of the vector. Number 5 is interesting. In the unit vector form, it's 4j. Now, because we're only seeing one part, all right, it only goes in one direction, you have to stop and remember that there are two unit vectors. Well, I should put a little hat on them. I is the horizontal vector, all right, the horizontal unit vector, and j is the vertical unit vector. So this is the vertical unit vector. So that means in component form, this would be 0, all right? There is no horizontal component, all right? So the horizontal component is 0, and comma 4, all right? Since 4 is the vertical component. All right, so just keep that in mind as we do the rest of the problem. So that is the component form. Now the magnitude, we don't need to do any calculations. The magnitude is 4. This is simply a vertical vector of magnitude 4. Or, looking at it in terms of unit vectors, it's literally 4 vertical unit vectors together. Either way you want to look at it, the magnitude is 4. Now the direction. Again, because the picture is so simple, the direction, we don't need to use inverse trigonometry or anything like that. We're dealing with a vertical vector, all right, of magnitude 4. So the direction measured from the positive x-axis is obviously going to be 90 degrees. Okay, so it makes it really simple when we have a horizontal or a vertical vector. All right, look at number 6. Again, I is the horizontal unit vector and j is the vertical. So this is horizontal. So a picture of this vector would look like this. It is simply going 7 units to the left. Okay, so the component form is going to be -7, all right, because that's the horizontal component, is that it's going to the left 7, and comma 0. The vertical component is 0 because it's not going up at all. The magnitude will just be 7. All right, the magnitude is just the length of the vector, and the length is always positive, so that's the magnitude is just 7. And the direction, if we put this on a coordinate plane like this, remember that the direction has to be measured from the positive x-axis like this. So that is 180 degrees. Alright, that's it for number 6. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.